There we go. So set up letter B. All right, anybody give me this fraction? Chances are you're correct, so I'm going to be too nervous about this. So Jake, what do you think?
A over 9 equals 3 over 5.
Good. A over 9. I think I need to do better. A over 9 equals 3 over 5. You didn't hear them at home. So the A over the 9 equals the 3 over the 5. So this is to this as 3 is to 5. You also could have done A is to 3 if we compare them in their positions on the top, and then do the bottom is to the bottom, so 9 is to 5. My guess is most of us did this. This looks like a fraction, so that's probably what I would go with. And then when you solve that, Jake, what'd you end up with? Although it's not a great number, is it?
Yeah, A equals 27 over 5 or 5.4.
Good. So 27 over 5, and then if we divide that, that would give you 5.4. Okay. So they're just in that proportion, you just set up that little fraction. So while A is about as easy as they would get, where you just do this over 9, 3 over 5, set up your proportion, solve that. C is a nice thought-provoking problem, so not as easy. So see if you could set up letter C. A lot going on there. And see what we think. I think everything has to correspond. So when you set up a fraction, just set up corresponding parts and then make sure that that is valid if we were to ask you what the corresponding parts are, okay? This one should make you think a little bit. Where's the corresponding thing? Whether it's set up the equation or not, what's the corresponding? Okay. Let's do it first. Do you agree that like 6 and X, those are both that top short band? So those are things that correspond. This full side, the corresponding all the way. Would that be full side right here? So like those correspond to each other. Doesn't Y take these two. So then Y corresponds to these full sides. So Y corresponds to all. Because if we start throwing it together, we also want to come up with a fraction where one side, where we would be able to eventually solve it. So just set up some things that are corresponding to each other and see if we can get to eventually a point where we have an equation and solve it. Stop the chat. Maybe you can practice up there. Okay, if you're trying this and struggling, so are the majority of people in class, so don't feel bad. And it is tricky for sure. Definitely a lot going on here. It's the first time you've seen this, so nothing to really fret about. It's one that is intentionally meant to make you think a little bit. Okay, Kaylin had one that I want her to give us, even though it won't necessarily give us an answer right away. Here's kind of what she set up, just in the idea of understanding corresponding parts. So the one that I asked you to give me, what was that? All right, so she put 6 over x. So she took this side here, this side here. So that goes between the first line, second line. So this is 6 goes between the first line and the second line on the left. The x is between the first line and the second line on the right. So those match up nicely. And then you set that equal to what?
8 plus 4.
And then she said 8 plus 4. So she got that here. That's the 8 plus the 4 she was referring to. So notice what that makes up. That's the distance between the second and the fourth line. So go to the right-hand side. Between the second and the fourth line, isn't that a y? So that's what she set up initially. Then she came to the realization that while that's good, 100% correct. So this is 100% correct. She came to the realization that if I have both an x and a y in my problem, does that get us anywhere in terms of being able to solve this? No. But that's what I was kind of telling somebody else. Just throw some things down that correspond to each other, and hopefully, if nothing else, we luck into sort of a proportion that's going to work. Okay, so she did this initially. That then gets us stuck because there's an x and a y. So then she kind of went along. I just overlooked your shoulder again, Kaylin, and the next one looked good. So now give me another one, same ideas, where we can actually now have one variable to solve for. All right, so she used 6 over x again. So again, these two black sides between the first and second and the first and second. And then what was your next one? So then she did 6 plus 8 plus 4. So understand what that is. Isn't that the entire left-hand side right here? 6 plus 8 plus 4. So if she's going to do the entire left-hand side, wouldn't she have to do the entire right-hand side here? What is the entire right-hand side? 12. Don't we now, once we add these, so she's ultimately going to want to add these guys together. So we'll do 6 over x equals, what is that, 18? Where this one over here had multiple variables and we were kind of stuck, did we now just come up with a proportion that allows us to figure out just the one variable? Yeah. Okay, so now we can go ahead, crisscross, multiply. 6 and the 7 is a 72. 18 and x is an 18. X, divide by 18, and we nicely get a 4. I didn't see any in here, so maybe at home. Did anybody get a proportion? Because there's now a nice way to get the y, so we can get y very easily now that we know x. But before we knew what x was, did anybody set up one that would allow us to figure out what the y was? Somebody? At home, anybody? All right, well, let's take y. So the only way we're going to be able to solve for y is by comparing it to its corresponding part. So look at what y is, and then in the denominator, write down what y corresponds to. Hopefully we can see that. So if I'm going to use y, what does it have to be on bottom? So look at what y covers. What's the corresponding part on the other side? All right, this we should be able to do. So Gael, what does y correspond to on the left-hand side?
8 and 4.
Good, the 8 plus the 4. It's what I have highlighted in blue. So between the second and fourth line is y on the right. Between the second and fourth line are the 8 and the 4. So I would do y over 12. Now I just need to come up with another fraction where I know the top and the bottom. So we have a couple of options. Don't we now know that x is 4? Let me get rid of this. You know what? We wouldn't have known it at the beginning, so let's not do that one. But we could use that one. Don't we have a completed fraction already that Kaylin gave us? Right? Isn't this a complete fraction? This is the entire left-hand side and the entire right-hand side. So we could have once again done that 18 over 12, and then we have another equation that we could quickly solve for. So if you had done y first, that's how we could have gone through and solved for this. Now, once we know though that x was a 4, so with what Kaylin gave us, even though I just erased it on accident, or just cross it out. So if x is a 4, what does y have to be then? Anybody do that math? Understand how we can get this without having to set up a proportion? So this whole side is 12, right? We now know x is a 4. So what did y have to end up being? 8, right? Y has to be an 8. So that 8 and 4 together will add up overall to give you that 12.
12 over 18.
12 over 18.
Y over 12.
What did I put?
You put 18 over 12.
We have we're at y over 12. Nope, you're good. You're correct. Thank you for catching that. I was just going to solve it too, so I would have not have gotten 18, which then would have told us to go back. Yeah, so I went right to left. Yeah, we definitely want to do the right-hand side, which is a 12, over the left-hand side, which is an 18. So now, if we solve this, it better give us an 8. Crisscross. So you'll get 18y equals 144. Divide by y, and like it should, it gives us that 8. And then we know the 8 and the 4 together gives us that full length of 12, and then we're good. All right? All right, so that one makes us think a little bit. Thinking is good, so don't freak out about thinking. All right, then real quick, the next page. We'll go through these. This is the old stuff. Just a little review again before we wrap up and get into a quiz on all of this stuff. So it's within that diagram to the right. Take parallelogram ABCD. So that's the one on top. That's the big one. And we know that that is similar to the parallelogram on the bottom or the smaller one. When it asks for the scale factor, it's basically the relationship between the two, the ratio between these two. So we want to compare ABCD, so the big one up top, to the EFG, the smaller one on the bottom. So do that real quick. Write down what we think that scale factor is. This we've done a number of times. This was on our homework the other night as well. What's our scale factor? What's the ratio from the big one when we compare it to the small one? All right, all we're looking for is what's the ratio from the big one to the small one. So in order for us to do that, we want matching. So let's look at these parallelograms. Here is the top of the big one. Here is the top of the small one. Do we know both of those values? No. So we don't want to compare those. If I go down the left-hand side here, left-hand side here, do we know both of those? No, so that doesn't do us any good. If I compare the bottoms, no good. We know this is a 15. We don't know what that one is. So to establish that ratio, we need a complete corresponding set. The only one that we know the complete corresponding set of are these right-hand sides. So those are the ones that we're going to use to set up our fraction, our ratio. I'm going to put the ABCD on top. That's the side of 10. And we're going to compare that to the corresponding side in the smaller one, which is a 4. So it's 10 to 4. Which if we reduce that down is 5/2, or if we like the fraction or the decimal version, 2.5. So what that means is whatever this one is, this is 2.5 times as big as this one. All right. If I want to find the length of E to F, I'm looking for this up here. So let's now deal with the idea that this is a parallelogram. So if this is 10, we know this is 10. If this is 15, we know this is 15. If this small right-hand side is 4, we know this small right-hand side is 4 as well. So we know most of the sides. The only two sides we don't know are the top and the bottom and the small one. We know they're going to be the same. And then now that's what I'm asking you to find, E to F. So we want to figure out, let's throw this down as our variable, E to F. Now we should be able to set up our proportion. like we've been doing here for this whole week. So one of them I would use is the 10 and the 4, right? We just used that. So let's take 10 to 4. So I'm going to go big figure to the small figure. So 10 over 4. So then on the right-hand side, write what that fraction is going to have to be if we're going to solve for x. And Paige, what do you think that's going to have to be? Good. That would have to be 15 over x. X is the top side. This is the top side, and we want the big over the little. 15 is big, x is little. And then from there, we should be good. Solve that. 10x equals 4 times 15, which is a 60. And then we know overall x is a 6. Once we know the top side of the smaller one is 6, that would also tell us the bottom one has to be a 6. It's a parallelogram. All right, last one that you have to think about a little bit that I want you to kind of do and think about. See if you remember how to do G. So find the measure of angle G. Old ideas. We have to recall. All right, anybody think they have this? Jake, what do you think? Good. Jake said that the measure of angle G is 142 degrees. All right, walk me through that, Jake. Where'd you get that from?
Both those angles have equal.
Both of what angles? What are you talking about?
Angle, well, I know that angle 38 has to be, angle 38 and angle C have to be, equal to 180 because it's opposite.
Okay, so Jake just said that this angle here and angle C have to be supplementary. We'll use a little better explanation. So that's perfect, 100%. He said those are supplementary. You'll say one of two things in terms of our thought process. Those are either consecutive angles. So we've talked about consecutive angles are supplementary. Or if we know these are parallel lines, so this is parallel to this, these are same side interior angles. We talked about same side interior being supplementary. So what he said is these have to add up to be 180. So you found angle C to be 142 then? Okay. So then he knows that this is 142, but we're looking for G. So then what did you think?
Well, like, what is it called? I don't remember what it's called, but angle A should be the same as angle B, so then that makes G also 142.
Good. So angle D and H, he said, have to be the same. They're corresponding angles in terms of the word you're searching for there. So good. The corresponding angles have to be congruent. So angle C, if that's 142, doesn't angle G then also have to be 142 because they're corresponding angles? So that's where we come up with this degree measure. Okay, good. All right, we have all this done. So find the perimeter real quick of EFG and then find the perimeter, if I remember correctly, that's the next question. Find the perimeter of both of them. So find smaller one, bigger one. So we're just adding up all those sides. All right, Ian Brooke, what'd you get for the perimeter of the small one? E to F to G to H.
20.
Good, so that should be a 20. We're just adding up all four sides here. All right, Gael, what do you get for the perimeter of the big one?
I got 50.
That should be 50. So if we then added up all the sides of the big one, we should get 50. Then it asks you this question. We should have been able to answer this question much, much earlier than what we would have had to have done here. So let's pretend these aren't even here. So don't cross yours out. But if those weren't there, I should have been able to answer this question much quicker than what we are doing right now. Because if you remember, doesn't the perimeter have the same ratio as our sides? So when I go up to letter A, and we would have found our scale factor or the ratio between our sides, see how it's a 2.5 or 10/4, however we wanted to write it? Notice what's now going to happen when we compare these two, as long as we do it in the correct order. The ratio of these, and it says of A, B, C, D to E, F, G, H is 50 to 20. That reduces down to give us the same ratio that we got at the beginning for the sides, 5.5 or 2.5. We could have answered that without doing all that work if this was simply your question, okay? All right, so with that, oh no, we have one more. Yeah, sorry. Finish the similarity statement and then find each scale factor. Do letter A, these hopefully we can do. So H corresponds to what angle in the other triangle? J corresponds to what angle in the other triangle? And then we're going to put those in the order. And then real quick, tell me what the scale factor is going to be. All right, so Victoria, what do you have for this triangle here?
Or like E, F, D.
All right, so she said E, F, D. So if you look at H, notice how that has 3 arcs. If you look at E, it also has 3 arcs. That's how we know those correspond. J had the 2 arcs, so Victoria picked the F because F has 2 marks, so then the D obviously going to have to match up as well. If we do the scale factor, anybody? We'll wait for that. Jake?
I did 24 over 18.
Good. Good. So make sure we pick up corresponding sides. So Jake gave me 24. So notice how 24 is in between the 3 arced angle, and this has 2 arcs. So the corresponding side over here between the second and the third is 18. So he said he did 24 to 18. And then what that become?
4.
Good. So our scale factor is just 4 to 3. All right. Letter B, let's do one more here. Go ahead and do your similarity statement and then your scale factor. All right, and Paige, what'd you get for the triangle first? What order? Good. So she said J, K, L. Sure, you're in P, M, J. Yeah. So she went from the right angle, 1 arc, 2 arcs. So right angle, 1 arc, 2 arcs. So J, K, L. And then our scale factor, Paige, what'd you get? Say that one more time. Yeah, it kind of depends. We are not specifically told one to the other. So what numbers did you use to get to? Good. So she took 20. So here's this side right here. She compared it to a 10. So there's nothing in the wording that says I want to go from here to here when we gave this. So I would take this, all right? This side is always twice as big as this side. My guess, most people did left to right just because we normally read left to right, you count left to right, you number letters that way. If you went left to right, you're just going to get what? What do you get? Yeah, you get 1/2. So either or. So if you put a 1/2 here or a 2, I would probably take that if we didn't specifically say which direction we're going to be going in. Okay. All right, real quick. Don't worry about C. You can do it if you want, but just with our time. Your homework is the next 2 pages. So it's going to be here, Math 2, 6.4, where it says the homework. Real quick, go to that last. It seems like a lot. Most of these require no work at all. Go to the very last problem set just so you understand what this is asking. It's saying which of the following could be sides of similar triangles. So when we look at this, what you're not given the triangles, those we've done a ton of, but what if we just give you these lists of numbers? So what this is kind of giving us is, since 3 is listed first here, it's going to correspond to the 6 that's listed first in the other set of sides. And we're just testing to see what that ratio is going to be. So for the first set of sides, our ratio is a 1/2. Well, the 5 is listed second. The 10 is listed second. So if we now compare those to find their ratio, notice how that would also be a 1/2. And then the final set of sides is the 7. The 7 compared to the 14, I'm not going to write it. Get the gist. And if I compare 7 to 14, does that also give us a 1/2? Yeah. So because all the sides have an equal ratio, you would then say yes. All right. And that's what you're going to do for those. All right. It's posted on Canvas. If you have any questions on it, anything we need to talk about, let me know before, at the beginning of class on Monday. But if you are at home, you guys are free to go. All right. And have a good weekend. All right. We'll see you Monday.